Hi guys, Mr. Leah here. This video is on conditional probability. We're going to be looking at dependent events. It's quite important that you've already watched my videos on the AND law and the OR law, particularly the AND law when we talk about independent events, where if two or three events are happening, the outcome of one won't affect the other one or the other two. In this case, though, we're looking at events where the outcome of event one will have an effect on event two. So what it says here, when events are not independent, in other words, dependent, the outcome of earlier events affects the outcomes of later events. This happens in situations when the objects selected are not replaced. Let's look at an example. A box of chocolates contains 12 chocolates of 3 different types. There are 3 strawberry, 4 caramel, and 5 milk chocolates in the box. Sam chooses a chocolate at random and eats it. Jenny then does the same. Calculate the probability that they both choose a strawberry chocolate. Now, in prior videos, what would have happened here is Sam would have taken his chocolate and then put the chocolate back in the box, therefore not affecting the probability for Jenny when she chooses hers. But that's not the case here. When Sam takes his chocolate, he obviously is going to eat it. So what we're looking to do is work out the probability of a strawberry and a strawberry. Well, initially, when Sam goes into the box, there are 3 strawberries out of 12. This is AND probability, so we're now going to multiply that by the probability for Jenny getting a strawberry. But the first thing we've got to do is take Sam's strawberry out. We're now left with 2 strawberries out of 11 chocolates being strawberry. So 1 less strawberry and 1 less chocolate. The probability of a strawberry and a strawberry therefore being 3 out of 12 times 2 out of 11, which is 6 out of 132. You can simplify that to 1 out of 22, but I would only do that if the question asks you to. Let's take a look at the second example. This time we're going to calculate the probability that Sam chooses a milk chocolate and Jenny chooses a caramel chocolate. Slightly different to the first example because they're both having different chocolates. So maybe less of an effect on the probability. Let's have a look. So the probability of a milk for Sam and a caramel for Jenny. Let's start with Sam. There are 5 milk chocolates here out of 12 possible chocolates. So the probability of him getting a milk chocolate is 5 out of 12. Once he takes that milk chocolate, there are 4 milk chocolates left, but this isn't important to this question because we now want a caramel chocolate. Now, there are 4 caramel chocolates in there, so the only difference now for the second probability is that there are only 11 chocolates left. So the probability of Jenny getting a caramel chocolate is 4 out of 11. Multiplied together, 5 over 12 times 4 over 11 equals 20 over 132. And again, we could simplify it if the question asks us to. And now maybe a question for you to try. Calculate the probability that Sam chooses a strawberry chocolate and Jenny does not choose a strawberry chocolate. In other words, Jenny chooses a caramel or a milk chocolate. Have a go, pause the video and restart it when you're ready for the answer. So, Sam wants to get a strawberry and Jenny a not strawberry, so anything other than a strawberry. Let's have a look at these probabilities. First of all, the probability of a strawberry chocolate for Sam is 3 out of 12. And then once he has taken this strawberry chocolate, the probability of Jenny not having a strawberry, there are 9 left in that box that are not strawberry out of 11. Multiplied together, 3 9s are 27, and 12 times 11 is 132. And again, if the question asks you to simplify, it would simplify to 9 over 44. Let's have a look at a different scenario, maybe a game of Scrabble. Jenny picks up 2 extra letters by mistake, so she's got too many letters in her set at the start of a game of Scrabble. Sam removes 2 of the letters at random from Jenny without looking. Okay, so Sam is going to take 1 letter and put it back in the pot, and then a second one, put it back in the pot, both random. However, obviously the probability of the second letter will depend on what he's picked as his first letter when he's putting these back. So I'm asking you to calculate the probability that he removes, and question A, 2 letter E's. Okay, so an E followed by an E, or the probability of an E and an E. To begin with, there are 3 letter E's out of the 9 letters that Jenny has. However, once Sam removes that letter E, we're now down to 2 letter E's out of 8 remaining letters. So 3 over 9 for the first E times 2 over 8 for the second E, giving 6 out of 72, simplified to 1 over 12. And now, part B, calculate the probability that he removes a letter P followed by a letter E. Why not pause the video and have a go at this one yourself? And if you have paused, let's start with the probability of the P, and then we'll look at the E and multiply them together. So first of all, the letter P, there are 2 P's there out of 9 letters. However, once removed, there are still 3 E's, so that is unaffected. But what is affected in the second probability is that there are now only 8 letters left. So the probability of getting an E is now 3 out of 8 rather than 3 out of 9, which it was initially. Multiplied together, 2 over 9 times 3 over 8 is 6 over 72, which simplifies to 1 over 12. Now an exam question. Peter has 10 coloured cubes in a bag. 3 of the cubes are red and 7 are blue. He removes a cube at random from the bag and notes the colour, but does not replace it. So these are dependent events. The second probability is completely affected by whatever happens the first time. He then removes a second cube at random. You're going to have a go at these. Now, read through them, pause the video, and when you're ready, I'll reveal the answers. And here they are. A red followed by a blue, which is 21 over 90. Again, I haven't simplified this time. It didn't ask me to. It's an exam question. I wasn't asked to, so I haven't simplified. 2 reds. What I will pick up on here, look, is by getting a red, first of all, not only have the amount of cubes gone from 10 to 9, but the amount of reds has gone from 3 to 2. 2 blues. And finally, a blue followed by a red. And another example, Peter has 10 coloured cubes in a bag again. 3 of the cubes are red and 7 are blue. He removes a single cube at random from the bag and notes the colour, but does not replace it. He repeats this for 2 more cubes. In other words, he's taken 3 cubes out. So instead of multiplying 2 probabilities here, we're going to be multiplying 3 probabilities together. Again, why not have a go at these 3 questions? And when you're ready, unpause and get the answers. So let's start with 3 red. The probability of red and red and red. So initially there are 3 out of 10 reds. If we take a red, that now becomes 2 reds out of 9. And if we get another red, that becomes 1 red out of 8. 3 times 2 times 1 is 6, and 10 times 9 times 8 is 720. Red, red, blue is 42 out of 720, and blue, blue, red is 126 out of 720. And we're getting towards the end here. What we need to look at now is the OR law. And this is where things get quite difficult. So far, every question we've done has had a prescribed order to what is needed. So it could be a red followed by a blue, or the letter E followed by the letter P. Okay. What if, though, we're allowed to get these colours or these letters in any order? Let's take a look at this example. Peter has 11 coloured cubes in a bag. 3 of the cubes are red, 7 are blue, and 1 is green. He removes a cube at random from the bag and notes the colour, but does not replace it. He then removes a second cube at random. So far, very, very similar to the questions we've done. However, How do we calculate the probability that Peter selects a red and a blue cube in any order? In other words, he could have a red and a blue, or he might get them in the other order, a blue and a red. And this is where we bring in that OR law, that plus law, okay? And we do them separately. So first of all, we look at red followed by blue. There are 3 out of 11 reds. And if we take a red, 7 of the remaining 10 are blues. So the probability of red and blue is 3 over 11 times 7 over 10. But then we need to add to that the probability of the reverse. Blue, 7 out of 11 times red, 3 out of 10. The first multiplication gives us 21 over 110. And the second one also gives us 21 over 110. And when we add these fractions, we just add the numerator. So 21 at 21 is 42 over 110. As a second example, calculate the probability that Peter selects 2 colours the same. Now this is an interesting one and takes a lot of thinking. In other words, Peter can either get red followed by red, so red and red, or blue and blue, or green and green. But for those who are thinking ahead, one of those options is impossible, and it's the green. Because if he takes the sole green in the bag, there aren't any greens left. So green and green is an impossible event. Therefore, we only need to look at red and red or blue and blue. For the reds, 3 out of 11 multiplied by what would then be 2 out of 10. And for the blues, 7 out of 11 multiplied by what would be 6 over 10. Working them out individually, red and red is 6 out of 110, and blue is 42 out of 110. But because we're allowed either, the OR rule means that we add these probabilities and get 48 out of 110. Now a chance for you to apply what you've learned. And I would say if you do this well, okay, you know that you've got this topic down to a T and you're ready to attempt exam questions. Let's have a look at it. Rebecca has 9 coloured beads in a bag as shown below. She removes a bead at random from the bag and does not replace it. She then chooses a second bead. Now, just in case you can't see the beads, okay, there are 4 black beads, 3 blue beads, and 2 red beads in that bag. And we have to calculate the probabilities for Rebecca selecting the following beads in any order. So as a reminder, for part A, a red and a blue could be a red followed by a blue, or a blue followed by a red. Same for B and for C. Why not pause the video now and have a go at these questions and then resume when you're ready. And let's go through the answers. First of all, a red and a blue, as we said, could be red and blue or could be blue and red. And when we work out both probabilities and add them together, we get the answer 12 out of 72. Blue and black or black and blue gives us the answer 24 out of 72. And finally, the probability of black and red or red and black, because of the either order could be 8 out of 72, add 8 out of 72, which is 16 out of 72. Notice again, I haven't simplified any of my answers here, purely because the question hasn't asked me to, okay? You may have, and it does not make you wrong, okay? And if you have, excellent stuff, I would say. Now, I hope this has helped you, and look forward to seeing you in future videos.